morning, everyone. So before we get started, how many people have no idea what PSR-7 is? OK, about maybe a third of you. How many people have used PSR-7? OK, much smaller group of people. How many people that know what PSR-7 is think that PSR-7 is going to be massively important to PHP? OK, about the same number of people. Awesome. Hopefully, by the end of this talk, everyone will think that PSR-7 is going to be awesome. So since a lot of you aren't even really aware of what PSR-7 is the HTTP message interface PSR. How many people are familiar with FIG? Not, OK, a fair number of people. They brought things like PSR-0, PSR-4, unhappily brought people PSR-1 and PSR-2. How many people are fans of PSR-1 and PSR-2? How many people hate it because of the tabs versus spaces thing? Awesome. Well, you're all Symfony developers, most likely, so you're probably already familiar with Symfony's CS, so it's probably not a big deal. There are a lot of people out there that don't like it, though. So PSR-7 tries to solve a couple of problems, and it solves two of them. And we're going to focus at first on the server side of the problem. So a little bit about myself. I've been programming PHP since about 2005, somewhere around there, like full-time doing PHP development. Around 2008, I got pulled onto a project that was heavily involved in Spring Framework and Hibernate in Java. How many people use Spring Framework or Hibernate? Oh, OK, handful of people. So I really liked what I saw there with the whole servlet thing. I liked the fact that there was this HTTP request object that sort of encapsulated the state of HTTP requests. So because I like to write frameworks, I decided to bring that back into my PHP world. And I created a little framework called Halo, which no one should ever look for this. If you look for this, I will probably cry. But it's still out there if you really want to find it. And I had an HTTP request class that basically brought in a bunch of stuff that represented the HTTP request. And I created a little dispatcher utility that would basically take all of the superglobals and create this object for me. So I thought I was pretty special. I thought it was pretty cool. No one ever saw my code because I was kind of a lone wolf. But it was fun stuff, and I was really happy about it. But after a while, I realized that spending time writing a framework was taking all of my time, and I wasn't actually getting any applications written. So I started shopping around for a replacement for my framework. And I ultimately decided to go with Symfony, because Symfony felt very familiar to me. It turned out they had a request object, too. It wasn't super special. The constructor looked almost identical to what I was used to already anyway. And they even had a factory method that did identical to what I was doing, was shoving all the superglobals into this request object. And really, it turned out that I didn't look hard enough because almost all of the frameworks had the same sort of pattern. Zen Framework has the same sort of thing. It doesn't have a factory constructor necessarily, but it does say if you didn't pass these things in, get them from the superglobals. Or has a similar approach. I haven't checked all of them, but I'm guessing most of the bigger frameworks that have sort of components at this point have this same sort of thing, where they have a object representation of the request. And they all pretty much have the same sort of thing for responses as well. So if you look at the response object for Zend, response object for Symfony, they're going to be somewhat similar. They have the same thing in common. And sort of what we've seen over the last, I don't know, maybe 10 years or so, is PHP developers have started to prefer abstractions over dealing with the superglobals. So people, us, we've all looked at this and said, you know what, I'd rather pass around this object rather than looking at _get, _server. It's just easier, it makes more sense. And this has had sort of a negative impact on the ecosystem for PHP. This is because you start getting vertical silos for Zen programs, Symfony programs, Laravel programs, Cake programs. If you start writing code around this HTTP abstraction, they don't go very well to the other frameworks. So if you write a controller in one application, it's going to be tied to the request object for whatever framework you're in. One of the big exceptions that I've noticed was that Symfony 2 sort of didn't fall into that trap as badly because of the way that they had broken down the components. The HTTP Foundation component and HTTP kernel component made it possible for more applications and more frameworks to sort of work together a little better. They could base their applications on the minimal amount of Symfony code that they could, so that you could start writing controllers that worked both in Symfony and Silex, You could also get it working in a Drupal and anything else that worked on HTTP Foundation. So a group of developers were sitting around in the Silex channel and started to wonder what it would look like to start passing around information at the HTTP layer instead of dealing with these framework silos. And that's pretty much where Stack PHP came from. How many people were here for the Stack PHP talk last year? Handful of people? OK. How many people have used Stack PHP, or used it in some way? OK. Not as many people as I was expecting. I asked that question at PHP Benelux, and the entire room raised their hands. So one of the interesting things I've seen about Stack is that it's really hard to get a grasp on who's using it, because nobody talks about it. Every once in a while, it'll come up in a blog post or some sort of conversation, but it's not like anybody advertises, hey, I'm using Stack, or Stack is awesome. But a lot of people tend to use it. It's just really hard to see who's doing it. For example, Laravel for Laravel 4, every Laravel request served 3 Stack middleware. It was a cookie guard, and there were a couple of others. So everybody who was running Laravel 4 didn't realize it, but they were actually using Stack middleware behind the scenes. So the other problem that PSR addresses is a similar problem, but on the client side. It's a little less fragmented, but the HTTP client applications and libraries are still suffering from the same sort of problem. So if you look at, like, say, the Geocoder project, they have to either make the decision to make people use the HTTP abstraction client that they want. Like if, say, you build something based on Guzzle, that means that your users have to use Guzzle as well. Or you have to write adapters, which, I apologize for this, that screen's cut off a little bit. If you want to write a curl adapter, you want to write a Guzzle adapter, a Buzz adapter, basically you'd have to provide interfaces for every single possible HTTP client implementation that you want to support, which isn't a very scalable solution. This means that every single library developer needs to be able to write their own adapters, their own interface for writing the adapters for all of these things that maybe people will want to use. It's just not a very good place to be, and in a lot of ways it's very similar to what happens on the server side as well. So the problem that PSR-7 addresses is the fact that these are all based around the simple HTTP message concept. And that should really be a commodity. There's no reason that you should have to tie yourself to a specific implementation of parsing HTTP messages. I mean, at the core, PHP does that on its own already. So we shouldn't have to say we're just Symfony developers building a Symfony 2 application and we're using HTTP kernel interface. We should be able to say we're writing PHP applications and here are the messages. Here's the request, here's the response. Whether you choose to use Symfony or Zend or Laravel or whatever application you want to use, that should be up to you as a developer, not dictated based on the fact that, hey, I'm writing a Symfony app, now all of my code has to be locked into Symfony. So how did we get there? How did we get to PSR-7? As we already talked about, this came from the Framework Interoperability Group, that's PHP Fig. Their whole idea is interoperability between frameworks. So something like PSR-7 is a great fit for what their goal is. PSR-7 started its life back in 2012. Benjamin Eberle proposed a relatively modest concept for creating a standardized client interface. So however you get the client didn't really matter, but once you had a client, you'd be able to feed stuff in. So this was to get around, at that time, what seemed to be like low-hanging fruit of the client problem. I don't want to have to write adapters for Guzzle and Buzz and curl and all of these other things. I want to have a client that you pass to me, and then I can just get requests of it or post requests to it or whatever I needed to do. So this sparked a really great debate. But then I think PSR-1 and PSR-2 came into play and sort of sidelined the discussion. During the discussion, a lot of things came up that the client interface wasn't going far enough. Some people wanted to have an actual request object or an actual response object. And as soon as people talked about that, they said, wait, server side has request and response objects. So the conversation got really complicated pretty quickly, and Fig itself just got sidelined for a little while. It wasn't until the very end of the year that Chris Wilkinson decided to come in and say, hey, let's take a look at this HTTP proposal again. And he sort of distilled the discussion that had happened months prior, basically saying that what we're really looking at here is the HTTP messages. We need to do that first before we try to build a client interface or a server interface. And what he proposed was not all that dissimilar from what PSR-7 turned out to be, but it is definitely different. So if you look at there was a common message interface that both request and response shared. Request interface kind of extended a little bit, gave it a different constructor signature, and the response interface, again, was just a little bit different than the core message interface. And then things got stuck for a very long time. So this was the end of 2012. It wasn't until the end of January 2014 that things started to pick up again. By that point, PHP Fig had a better workflow in place so that you knew when PSRs were going to get numbers and whatnot. So PSR-7 was assigned PSR-7 as the number in January of 2014. And Michael Dowling, the author of Guzzle, had sort of picked this up. He was running along with the project and said, you know what, I've decided now that Guzzle would benefit from this. I think everybody would benefit from there being a common client interface. So he ran with that until people started to push back again and say, you know, we really need this to be a client interface. Maybe we could do a client interface, or sorry, a server interface in addition to a client interface. And the number of interfaces like doubled. It got really complicated really fast, and Michael sort of took a step back and decided at the end of August, you know what, I'm not going to do this anymore. I want this for Guzzle. I don't really care about the server side. And you know, he was getting hit from all angles. A lot of people were coming in with different ideas, so he just sort of wanted to step back for a little bit. So at the time, I was one of the sponsors for the PSR. I was super excited about it, and now it was gone. You know, I had a vested interest in it because of my work with Stack. This whole idea of sharing HTTP code was just really important to me. So I was kind of bummed. I was sitting there, I'm like, I don't know what to do. About a week later, I get a tweet from Matthew Wirro-Finney. Is anyone who knows Matthew Wirro-Finney? He's one of the Zend authors. He sent me a message and said, hey, what's up with PSR-7? I'm like, well, I don't know, it's canceled. No one's working on it right now. I don't know what you expect me to say, it's canceled. And he said, I really need to talk to you. And I was like, okay, sounds good. We were both going to be at Madison PHP a week later, so I said, let's meet and talk. So we did, and what he wanted to talk to me about was the fact that he'd been working on a package at that time was called Fly HTTP. He was super excited to talk to me about it. He said, I made PSR-7 work as is on the server side. I have a whole package. I was just getting ready to release it when I saw that it had been canceled. So all of the people who were worried about whether or not PSR-7 made sense as a server side could look at this and say, hey, you know what, this actually works. It's been implemented. We know that this can work. We don't have to be worried about it. And a lot of his inspiration for this had come from his work with, I think it was Node. He was doing a bunch of stuff with Node, liked how all of Node basically used the same request and response objects everywhere. Everyone could interoperate between their libraries really easily because of the way that the messages were passed around. So he wanted to create something that was similar to Centric Connect that did stuff with middleware. Like he liked all that middleware stuff he was doing. And he thought about it and thought, you know what, I want to do this in PHP. Is anyone doing this? So he looked and he found Stack and thought, wow, this is great, except it's tied to Symfony. And he didn't, you know, as a Zend person, he didn't really want to invest a lot of time and energy into making his brand new middleware concept stuff tied specifically to Symfony. And he said, what we really need is to have a common HTTP message. And if you go back to PSR-7, that's exactly what we were solving. So what he needed was PSR-7, and that's what led him to find PSR-7 and create Fly. So what he was looking at here when he talked to me, and I'm sure he talked to other people about this as well, was basically looking for support to see whether or not PSR-7 should go forward. And a week later, he decided it should. And so he picked up where Michael Dowling left off with PSR-7 and basically ran with it, with the full intention of making it both a client and a server interface. And he pushed really hard, and less than 7 months later, PSR-7 was accepted. And so given all of the false starts and, you know, what is it, 2-3 years worth of work on PSR-7, the fact that he managed to push it through in under 7 months was awesome. So he worked very hard on it. We got a lot of people involved. It was really awesome. So 3 days before it was accepted, I gave a talk very similar to this at PHP Day. And Karen, I'm not sure if I'm getting his name right, Karen asked me if I knew of a PSR-7 implementation for Symfony. And I didn't. I hadn't heard of anyone making that yet. So he was kind of blown away because no one had created this yet or even had started looking into it. But less than 2 weeks later, Symfony had a full PSR-7 bridge. How many people have heard about the PSR-7 bridge? Awesome. So what this meant was anybody who used Symfony 2.3 or higher could automatically start using PSR-7 requests in their controllers, which was great. This means that people can start using this right now. So any of the stuff that you learned today, you can start using right now in Symfony if you enable this PSR-7 bridge. There's a little bit of overhead in the conversion process from the Symfony request into the PSR-7 request, but if you're okay with that little hit, you can start writing code that can be portable to other PSR-7 frameworks right now. So this was a big thing that Symfony was able to pull this off. It was super awesome. And I don't know who all was involved in that, but whoever it was should get like a hug or something. I don't know.
That's PSR-8.
PSR-8, yes. PSR-8 is the hug interface. It was an April Fool's joke last year or this year. So if anyone's looking for the numbering scheme, it really is. It doesn't mean anything. PSR-7 is HTTP messages. PSR-8 is hugs. So the numbers don't matter. So we're going to look a little bit closer at PSR-7 itself. I'm not going to go through a big high-level thing or a big low-level dive into this. We're going to look at some of the concepts and just a high-level overview of some of the interfaces. So there are 7 interfaces that make up PSR-7. There's the core message interface, and that is the base for both requests and responses. And there is another server request interface that extends the request. And what this is used for is kind of the bridge for the superglobals, access to those things that PHP developers would normally use. Whereas if you're looking at a request from the context of something like guzzle, you don't care about $_get or anything like that. So that's why those interfaces are there. The request also has a URI. This is because when a request comes in or a request goes out, it has to know which URL it's trying to access. And there's also a uploaded file interface that encapsulates the multi-part file uploads. And then there's a stream interface that both uploaded file and message uses. Probably one of the more controversial parts of PSR-7 is it introduced the idea of immutable parts, immutable objects. And what this means is that every single method that does something to the request or response actually does it to a clone. So this means that if you try to create an object and call the with methods, it sort of looks like your standard Fluent interface. But if you try to do this without capturing the response, it's probably not going to do what you want. So what you probably want to do in this case is reassign the value. So if you're just doing like a chain and you're automatically passing that chain on, it works great. But if you're trying to change a variable in place, you actually have to reassign it. So this is one of the things that people looked at and were really skeptical about. How many people have tried this and thought it was kind of weird, or looked at this and thought it was kind of weird? Nobody? Okay. Awesome. Well, there were a lot of vocal people who didn't think this was very good. And this is one of the things that could bite you if you start trying to play with PSR-7. So just remember that if you try to set something and it doesn't seem like it's sticking, it's probably that you need to reassign the variable. So if you start working with this now, that's something that you might run into. The messages themselves were basically parsing a simple formula of a message line, status code, version, and then a collection of headers, and then some body. So we'll look at how the headers are handled first. It's pretty standard. It's pretty similar, I think, to how Symfony would do it if there were no header bag. So that we decided not to implement the bag concept because it was kind of this amorphous thing. So we decided to actually implement it as methods. So you have to actually ask for a specific thing off of the message rather than saying, like, the header bag, do something with that. You can ask it if it has a certain header. There's a consistency in how things are done. So if you ask for the header line, it'll pass back a comma concatenated string of all of the headers of that value. So if there's multiple values for that header, it'll give you a comma concatenated list. If there is no header, it'll pass back an empty string. So it doesn't pass back false or null or anything like that. If you call getHeader, it's always going to, or if you call get header line, it's always going to pass back a string of some sort. If you call get header, you get back a list. So if there are multiple values, you get multiple values in the list. If there's just one value, you get one value in the list. And if there's no values, it's an empty array. So you always get an array. You don't have to worry about doing some sort of type checking on any of those. Or you can call get headers, and that gets you a key value pair where the key is the header name and the value is a list of the values. There's one oddity within the interface, and that is if you call a request and pass the URI, it will automatically update the host header with the host from the URI. This was done to help users who would probably just assume this would happen anyway. This was one of the more controversial things right at the end where we added a preserve host argument to the with URI command. Some people weren't super happy about this, but this was kind of the best compromise we could come up with. So this is to support people who deal with proxies, perhaps, where the host header in the actual request is different from the URI that is handling the request, I guess. So you might have a host header, but then you're actually connecting to a completely different web server to make the request. Streams. All of the message bodies were implemented as streams, and this was actually something that a lot of people had issues with as well. But this was done so that it was possible to use PSR-7 to work with large message bodies. It turned out that we were able to do some nice things with simple cases like just writing a string. If you set the underlying stream to be PHP memory or PHP temp. So there was a way to get around this, but it was something that people looked at as kind of an unneeded complexity, but it really made the interface a lot simpler to only ever deal with streams rather than having the interface sometimes do strings, sometimes do file handles, sometimes do streams or whatever. This simplified things quite a bit to standardize on everything being a stream. Another side effect of using streams that was a little unfortunate is that streams you can't enforce the immutability of streams. So if you pass around a request object, for example, that you expect that it's immutable, so every time you make a change to it, you don't think you're changing the state of the original request that came in. If you read the request or write to the, if you read the request stream, write to the request stream, or make any sort of change to the request stream, that actually is going to impact all of the copies of the request. So this was actually a reason that some people pointed at as saying, if we can't make that be immutable, then none of it should be immutable. But ultimately, the team decided to fight against that concept and say, you know what, it's fine. If this is the one thing that can't work, people can work around that. So this is one thing to keep in mind, though, that if you're dealing with if you're trying to get used to this immutable nature of these messages, that if you start dealing with the stream, that may actually impact how the code runs, or may impact things in places that you didn't expect. Requests, they added the concept of the URI. The URI is actually a really good example of how the immutability can be nice. So for example, we set the user's URI here. We're set a base path, so we say URI with path, URI with path. So these are going to be completely separate copies. And if we say user's URI with query limit 10, this doesn't impact the original user's URI, so when we use it down here, it still has its original state. So you can change things just before you pass them in, and it doesn't impact anything else. So the URIs are actually an interesting place to look at it, saying that this immutable object builder pattern type thing is actually pretty nice and can be useful beyond just being the way that it was implemented. Server requests, they add on some bits for handling the CGI stuff, handling in the underscore cookies, underscore post, underscore get. It's basically what most of you will probably be using from the server side of the stack. Because this is where you get all of the information from PHP. Server requests also have attributes. How many of you know about the request attributes in Symfony? A number of you. Okay, it's basically what an attribute is. It's kind of like a header bag of sort, or it's kind of like a bag of sorts that lets you attach little bits of data to a request. So it's usually a key value pair, and so like for example here, something is going to look for the country for the IP address that is on the request, and you can attach geocode.country and a value to it. So somewhere else in a controller or some sort of event handler, you can then look to say, hey, go get the country code from this request. If it's there, do something with it. So PSR-7 has the same concept. A lot of people will use this, or a lot of frameworks use this to capture the controller that needs to be run, any of the parameters. If you use parameter converters in Symfony, I think that the parameter converters are leveraging the attribute system as well. Uploading files. So if you upload multiple files to a PHP application, you might hope for something reasonable like this, where you would get the values broken out nicely. But if we're PHP developers, so we get to deal with some other weird construct that makes absolutely no sense to anybody. It's different if you upload one file. It would look like this. If you upload just this part, if you upload multiple files, all of a sudden it's broken up in a weird way. So one of the things that actually the Symfony community brought to PSR-7 at the last minute was the idea to normalize files, so that however you deal with them, whether you upload one file or 10, it's always going to be handled the same way. So it normalizes the structure for people so that you don't have to deal with PHP's oddity of handling things if you're uploading one versus many. PSR-7 also tries to protect the file name. This was something that was a little uncomfortable for some people sometimes. But basically, we don't allow you to get the underlying file that was uploaded. You can get the client file name, but not what it was on disk. And this was because in some cases, people might be uploading things by a stream. We don't really know what's going to be there. So the implementation for PSR-7, or the implementer for PSR-7 needs to implement move to. And this will allow you to basically, behind the scenes, do the is safe, all of the safe methods for uploading files by the implementation so that the actual user doesn't have to worry about that. There's also a, yes?
So you don't know what the original file name that they uploaded was?
Right, you get it from client file name. So the question is, do you know what the original file name was? You get access to the client file name, the client provided file name, but if it's uploaded to /temp/ some string, you never get access to that file name.
Okay, right, okay. Where it got placed by the server on the disk, you don't care what that's called?
Right, yes, you don't care what it's called on disk. You don't care that it is a file. It could be a stream or something. So you'd be able to copy it as a stream. So it's treated as a stream, so you should be able to copy it to another stream. So you could upload it directly to S3, for example, as a stream. So we wanted to abstract out this idea that there is even a file because there might not be one always. So, but it is up to the implementation, the PSR-7 implementation, to do things to make sure that it's safe to move the file. So behind the scenes, it should still be doing, is uploaded file or move uploaded file if it's appropriate to do so. Does that answer the question? Yes. Okay. Excellent. The server request also has a parsed body. This is kind of an interesting concept that I haven't seen a lot of people play with too much yet. If the content type is the standard www form URL encoded or multi-part form data, the content of the parsed body should be the contents of post to start with. However, if you want to write a middleware or some sort of process somewhere, you can actually replace the parsed body with something else. So for example, if the content type is application JSON, you can JSON decode the content and put it in the parsed body so that anyone that uses this request down the line can just know that the body is going to be, or the parsed body is going to be pre-parsed JSON. So maybe you want to do something like a HAL middleware where you know that the request coming in is the HAL content type, so you can create this to be like a HAL object. So you could parse the request right then and there into a HAL object, pass the HAL object into the parsed body. That way, all your controllers now can just say, get me the parsed body, and it's the HAL object that you'd expect. So it was this idea to sort of help things along with doing some of the more advanced content type negotiation things. Which brings us to middleware. Middleware, how many people, there weren't a lot of people that used Stack. How many people have used middleware in PHP or other applications, or other languages? Okay, maybe about a quarter of you. This is an example of a middleware signature. So it takes in, it's going to take in a request, it's going to take in a response, and it's going to take in the next thing in the stack that needs to be called. So this would be an example of a simple pass-through middleware where we're just passing request and response into next and then returning the response. So the job of next is to return the response that next created. So if we wanted to actually do something useful with this, I use the term useful loosely, we could say, for every response that we get back, we're going to add a header to that response and then pass that response back. So this is an example of this immutable design where we're saying we're not actually changing the response, we're creating a new response with an additional header into it. So it's a copy of the response with a new header. Not everyone gets the luxury of dealing with just anonymous functions like this. So if you want to create this as an invocable object, you can, which makes any class callable. So it's the same thing. So now you have something that you can pass around to other places. So if you want to tie this into Strategility, Strategility is the renamed version of Conduit. Matthew Werofany gave Fly HTTP and Fly Conduit to Zend, and they both got new names. So the new name of Conduit is Strategility, and it's basically a middleware interface similar to Centric Connect. So if you want to use this new middleware we've created, all you have to do is pass it into the pipe and instantiate a new version. And now any request that comes through this middleware pipe app will automatically have this header added to every response. If you want to use something like Relay, which is another middleware implementation, another PSR-7 middleware implementation, it's a similar thing where you pass in a bunch of middleware and you call Relay and it adds everything to the request. So in both cases here, it's pretty simple to add this little trivial bit of code to multiple frameworks, multiple PSR-7 compatible frameworks. So Stack's ultimate goal was to try to get reuse at the web layer. And what that really means now is trying to write framework-agnostic HTTP libraries. And I don't have a lot of examples of this, but I've written one, so we're going to talk about that. One of the things that people talked about a lot during the PSR-7 process was there were things on the request object that weren't handled very well, or at all. So for example, there was no way to get the cookies off the request object. Well, people then didn't realize that actually you need them on the response object as well. And then what about the content negotiation headers or the accept type headers? Or basically there's this unlimited number of headers that we could have tried to handle explicitly with PSR-7 that we decided not to. So we decided to say all headers are equal. And so if you want to write something to handle the headers explicitly, you can. So after hearing a lot of people coming back and saying it's not going to work, it's not going to work, I kind of put my money where my mouth is and decided to write a library that lets you deal with cookies for PSR-7 requests and responses. And it turned out to work about as well as we expected, the proponents of PSR-7 expected. The only downside, if you want to call it that, is you have to pass in a request when you get things, which is fine. But if you want to write a cookie, you have to pass in the request again and get the request back. So basically, it just encapsulates getting the request headers, rewriting them, assigning them onto the request, and passing the request back. Because again, the requests are immutable. So every action that requires changing a request, you have to save it back out again. So it became super easy to deal with cookie headers in a way now that anyone can use. Anyone who uses PSR-7 can use this library to read and write cookies. If you want to write a Symfony application and you need cookies, you can use this library. If you want to write a Zend application that needs cookies, you can use this library. You can write your own if you want to, but you no longer have to. And this also means that Zend no longer has to, and Symfony no longer has to. Nobody has to write and implement all of these things anymore because we can start writing libraries that can be used anywhere that PSR-7 is used. So I took it, let's see here. Yeah, so this is an example now of the response cookies. So Request cookies are cookie, and response cookies are set cookie headers. So the set cookie headers are just identical. They're almost a mirror to what you would see on the request cookies. So I took this a step further and created a middleware as an example of showing people what a middleware might look like to encrypt cookies. How many people encrypt cookies currently, or use a system where the cookies are automatically encrypted? Okay, not very many, but one, awesome. So the idea here is that when the request comes in, the cookies are going to be encrypted. We're going to decrypt the cookies and get a new request. And this request has the same exact values, except that now certain cookie values will be decrypted. We're going to pass that on to our application. So now our controller can deal with these cookies as if they're plain text. So they can read the plain text values. They can write plain text values back to the cookies. And then when the response comes back, we encrypt the cookies that we're interested in. So outside, before you get into this middleware, cookies are encrypted. Anywhere after this middleware is executed, they're decrypted. And when it comes back out again, they get encrypted. So anywhere outside of this middleware, the cookies are going to be decrypted. Anywhere on the inside, they're encrypted, or the other way around. So it's a really nice way to show how you can basically block stuff on one side and do things in a certain context, and then your application itself can deal with things completely differently. And so you could add this after the fact, after you've written your application, and upgrade your application to using encrypted cookies without your application even knowing about it. So the middleware pattern can be super powerful for cases like this. Probably the biggest library / application that I've seen talking about moving to PSR-7 is Glide. Has anyone seen Glide? It's an image manipulation library. It's actually like a server implementation where you can, it will automatically resize images for you depending on the request that you give it. So Jonathan asked me, hey, I want to do this. Does this make sense? And I said, it totally makes sense. And after talking to him about it for just 2 days, he realized that this was the future. He was going to be able to rewrite his application so that Glide at the time was basically tied to Laravel, I believe. But it didn't have to be. It was tied to Laravel. At the very least, it was tied to Symfony's HTTP Foundation. But even that was going to take a little bit of work, but he was almost there. But he realized that if he took it just one step further and just a little bit more work, he would be able to make Glide able to be moved basically between anything. He'd be able to move Glide to a Zend application, a Symfony application, Drupal application, basically anything that supported PSR-7 could take advantage of Glide now. So it was a really nice thing to see someone looking at this project and seeing how they could apply it to make this massive change to their code that would basically open them up to pretty much any PHP framework out there. So as far as frameworks, there are actually frameworks now that are PSR-7 first-class frameworks. Zend Expressive is the most recent one that I've seen come out. It looks like their approach is more along the lines of like a micro framework, closer to maybe Silex or Lumen than a full stack framework, but they provide enough tools to be able to create like templating layers and things like that. Radar, if you're into the ADR pattern that Paul M. Jones has been trying to get people to use, he's written a ADR-compatible PSR framework called Radar. Slim 3 was probably going to be the first big pre-existing framework that was going to be completely PSR-7. I think they're RC1 now, so they're getting very close, but they were pretty instrumental in helping to pull all of this along, as they were an actual pre-existing framework that was actively trying to port to PSR-7 through the process of getting PSR-7 approved. As I mentioned earlier, I like to build frameworks, so I've actually started to write a PSR-7 framework myself. We'd been using Laravel and kind of toying with the idea of moving to Lumen. I also tried with the idea of doing Silex again. I've done Silex a lot in the past, or maybe like a trimmed down Symfony 2 full stack. But I really wanted to see what this would look like to sort of put these ideas into action. So I really liked Laravel's container. It's an auto wiring container. Nikki C fast route. I wanted to use like a really quick routing component. And then I wanted to see what Relay was like for middleware. So the first thing I did was I looked to create a fast route middleware. And there were at least 2 implementations that I saw that were in existence when I started to do this. They both basically did the routing layer and then immediately dispatched actions. So I wanted to decouple the dispatching of the actions from the actual routing. It's probably pretty hard to see because it's at a switch aspect ratio. This is pretty much the bulk of the middleware. It does a typical dispatch. So if you already have a fast route dispatcher, how many people have used fast route dispatch? Okay, it looks like a couple of people. Dispatch it, you get the route info. The route info basically has a little bit of information for what you need to do. So if the route information or the route info came back with not found, I return immediately the response with the status 404. So I don't even go any further into the application if this happens. Same thing for method not allowed. If it's found, the action that needs to be taken is in index 1, and the parameters, if there are any, is in index 2. So what I do is I add those to the attributes and say, this is the action, these are the parameters, and then go ahead and go on into the next middleware. So this middleware doesn't do anything except track which action and which parameters should happen based on the fast route. So then I created an action middleware, an action handler middleware, and its job was to look for an action attribute and then resolve that attribute or resolve that action to a handler and call the handler. So this is similar to some of the stuff that happens behind the scenes in Symfony's framework, where you're calling into, I can't remember which one it is, but there's, I think it's the controller handler or controller resolver. It's a similar thing. But right now, this could come from anywhere. So this doesn't have to come from the router that I wrote. It could come from another router that someone else wanted to write. So the way that the framework that we're writing works, and this is pretty much the bulk of it, is we create a middleware queue. The first thing it does is route. It leaves open room to do other middleware. And then the last thing it does is it calls the action handler. And this is as much as you need to do. If you want to write a PSR-7 middleware-based framework, you could write this right now with just this little bit of code. We get the relay application from the container, pass in a server request instance response, and it runs. So it runs through everything to figure out where it needs to go, gets the response, and sends it back. As far as tying this to a specific implementation of PSR-7, we're right now using Zen-Diactros, which is FlyHTTP's new name. And this is actually the PSR-7 implementation behind the Symfony's bridge, the Symfony PSR-7 bridge. So right now, all we're doing is returning server request factory from globals anytime someone needs a server request interface, or we just return a response instance. So if you wanted to write your own implementation, you could write it however you want to. If you want to switch to some other implementation, like maybe Guzzle's implementation of PSR-7 does something that you like better. Maybe you want to just pull out Slim's implementation instead of Zen-Diactros, you could do that. So this is the only part of the application now that cares about which implementation of PSR-7 works or is used. And the same code, the same controllers, the same everything, the same middleware should work regardless of whose implementation you're using. So one of the downsides to the way that PSR-7 came about is that it's just the messages. And this is only a downside from some people's perspective. It's actually one of the bigger, probably more valid complaints that we've seen about PSR-7 is that there's basically no HTTP kernel interface. There's no request interface, which was Benjamin Aberle's original proposal was the client interface. This needs to be a client. We need to know how to do things with these messages. This is something that we're actively working on. A group of us are still working on this problem. But if we were trying to do this as a part of PSR-7, we wouldn't have PSR-7 right now, because everybody thinks, everyone has a different idea about how this should be used. So I think it's probably going to make a lot of sense for us to take at least a year or two to sort of let these things fall out and see which middleware signatures make the most sense, which client interfaces make the most sense. I think that people are just naturally going to gravitate to one or two preferred directions. By far, the biggest number of interfaces that I've seen used right now is the request, response, next signature for either middlewares or controllers. But even that, some people like, why am I passing in the response object? And there's a lot of people who kind of push against that and they don't want to do that. So I don't know, we'll have to see. But this is something, if you're looking for this right now, you aren't going to find a common request interface or a common client interface or a common server interface. If you want to look at actual implementations of PSR-7, like full implementations, Zendiactros is probably the canonical one. That's the one that Matthew Wirofini wrote as he was building out the PSR-7, so he kept that up to date the whole time. Slim, as I understand it, is a complete implementation, as is PHPixie. Guzzle's implementation is mostly complete, except it doesn't do the server side, or it doesn't do the server request interface. It does everything else, though. So if you're looking more from a client perspective and you want to have client-oriented interfaces and you don't need the server request interface, then you can totally look at Guzzle's implementation. There are a bunch of bridges, integrations, people using PSR-7 now, and this list grows every day. I'm basically losing track of all the people who are using it. Strategility is probably one of the big ones if you want to look at middleware. Symfony Bridge, of course. So if anyone here is already working in a Symfony project, you can add the Symfony Bridge to your application pretty easily. And then you can just start writing these applications. Convert one controller to a PSR-7 application and see how it works, see how it feels. So you can do that right now. This package here, this Oscaratorero, there's a PSR-7 middlewares package. I think there's like a dozen different middlewares in there. Everything from routing to firewalls to adding HTTP basic auth to your application. There's a ton of middleware in there. So if you're looking for ideas for what people have actually built for middlewares, this is a good place to look. So that's it for now. I'll be happy to answer any questions that there are on any parts of this. Yes?
Hi. So what was the main problem you tried to solve with the immutability of those message objects, for example?
What was
the main problem you were trying to solve by making those objects immutable?
Making them immutable?
Yeah.
So the immutable, the reasons for making them immutable are many, and I don't really have. I think the best reason was that state is dangerous. Changing state is dangerous, and a lot of users have pushed back on it. But a lot of the framework vendors have come forward and said, yes, we've had so many problems because of state. It would be great if there wasn't state anymore. So even though a lot of users have looked at it as something that they didn't really want, or they thought it felt weird, almost all of the big vendors, Symfonies and I can't think of who the other ones were that stepped forward and basically said state is bad. Like if we could take state out of our system right now, we would, but everybody's relying on it, so we can't. So there was a lot of pressure against immutability, but there was even more pressure for it. And the biggest reason was that if you have state changing throughout the system, you don't know what caused that to change. So if you're looking at your request object at the end of an execution cycle, and it's not what you expected it to be, you don't know where that happened. Whereas if you were passed explicitly a request object, you can trace back through and find out where that changed. So if you look at some of the, so here, for example, like if I had done something with request here, down here, I know that this request is identical to this request. There's nothing that changed. Even if something in here happens, or if something inside of this handler happens, I know that this request object is always going to have the same value. So that was the value that the immutability brought to it, is that you would always know exactly what state your objects were in because they couldn't have changed. Which is why with the streams, it's a little difficult because the streams break that. So if a stream breaks, there's really no way to protect against that. I don't know if that answers the question very well.
Yeah, I think so. But
okay.
Are you aware of, I mean, did anyone complain about the overhead that might have on a unit testing strategy around those objects?
Yeah,
Because
so there were actually a lot of people who thought that it would be a performance penalty to have this, and we actually did some benchmarks, and it was negligible. Like the amount of writing and rewriting that we did, it just wasn't going to matter. If your bottleneck is in the time it takes to clone a request, then it's probably not even a problem at that point.
yeah, well, I wasn't talking about the fact of cloning the request itself, but just returning a different object with all the implications that I have with a mocking engine, for example.
Right.
So you need to, your mocking strategy becomes like much more complicated when you code test around those objects, right?
I guess I'm not sure about that then.
Okay.
I know that the overhead we looked at was specifically that not necessarily that it was cloned, but that it was creating multiple objects. So whether I don't know if cloning or not makes a difference in the case that you're talking about. So yeah, I haven't seen anybody really complain about performance or overhead or anything like that with this style of immutable objects. Does that answer? Okay.
There's a question.
Yeah, I've got a question about the same thing. Doesn't this create multiple version of true? Because if you have a request object at the beginning and then you create new request object with every middleware, that means that actually each of these objects are different. So it's like a multiple version of the same thing.
Right. So the source of truth should be where you get it. So I know that the source of truth for my request object, for where I'm at in this context, is here. And so whatever happens to the request object down here, I don't care about. I'm not supposed to care about it. So if I want to make changes and then pass that request change down to the next stack, that's great. But the upper layers don't care about that. They only care about what they knew at the time. So it doesn't change. It shouldn't change. And if there are cases where it should change, maybe that should come back in the response object. Like if you need to pass information back up the stack somehow, maybe there are other ways that it should go back instead. So I haven't seen anybody complain about it, but I don't know how many people have tried to do that sort of thing or what their use cases were. Almost everybody who has come back and said, this looked bad, I don't want to do that, it's going to make certain things harder, they've tried it and then found out that they've like eliminated half of their code and made things easier. Matthew Werofany himself was in that camp. Larry Garfield from the Drupal he's the representative for Drupal for Fig, did the same thing. He thought it wasn't going to work very well. He actually created a complete implementation of Stack. I think he called it Stacker. That was PSR-7 compliant. And so basically rewrote HTTP kernel interface and found that he had absolutely no problems with anything he wanted to do and actually made the code a lot tighter and cleaner, and it made a lot more sense because you no longer had to worry about what happens if the request object changes. You just know it doesn't. The response object that you get back is the response object that you're going to deal with. It doesn't matter who changed it or how, that's what you have. So this, when I get the response object here, I'm not doing anything with it in this case. That's the only one I care about. I know I got back the response, I'm going to make some changes on it. No one's going to be able to change it, as far as I care, within the context of this bit of code, that anything else has changed. So that's what the immutability gives you, and it does seem pretty like abstract why that should matter, but like I said, most of the framework vendors have all come back and said state is a killer. If we can get rid of state within our request and response objects, it'd be amazing. And so they were all very much behind this. So it doesn't. Again, I'm not answering the questions very well, I don't think, but does that sort of address it a little bit?
Yeah, just understand that request is not a data object that you should pass around.
Right. Request is not a data object that you should pass around. Yeah. Okay. Yes?
Hi. So under what circumstances should we as Symfony developers start using the PSR-7 bridge in our apps?
At what point should you start?
Or can you give some examples? Like why should we use it? To do what?
So why would you use the PSR-7 bridge right now? If you want to start writing code that could potentially be portable to other frameworks. So for example, Glide was a really good example of this, where Glide was basically a server interface for taking in basically an image file name or some sort of hash that represents an image file name, along with some attributes or query parameters perhaps, saying this is the width I want, this is the height I want, and this is the kind of cropping I want. So it was actually a controller that read in that information. And right now, that the original controller extended Laravel's controller. So what he wanted to look at was, instead of extending Laravel's controller, extend maybe, extract out the code that actually does the work and create a controller that was maybe a Symfony controller that could be used by Laravel, but also Symfony users. Well, if he took that one step further, he could write that controller as a PSR-7 controller that now can be used by Laravel and Symfony by way of the PSR-7 bridge. And if you did that, that means that Glide can now live inside of Zend Expressive. It could live inside a Radar application or a Slim3 application. His application, Glide, which was at its core like boiled down a controller for HTTP handling to create images, can now move between all of these. So if you want to write code that can potentially move to different places, you can use that now. Yeah, does that answer the question? Okay, awesome.
Yeah, I have time for... So obviously a lot of cloning. You already had a couple of questions around it.
Yes.
But does any of this cloning actually affects the application when you're handling files specifically, anywhere?
Files as in like the streams?
Yes.
And that is one of the things that comes up as one of the issues. If you are dealing with the streams, if you're touching the streams in any way, you could potentially be changing the state of the other objects. So if we look at here, if I did something with the request here, like if I did request get body, write something to it, that would change my copy of request, but that would change the copy of the request up in the stack as well. So whatever middleware executed before this would also have that same state change for their message bodies. Whereas that's the only case where something like that happens. In any other case, any other attribute that could be changed on a request or response, it doesn't do that.
So that's where probably you don't have that much of a hit in terms of performance.
Yes, we aren't exactly. We aren't copying the whole file across. If you have a 10 megabyte stream buffer or whatever, it's not copying that across. Yeah. Yep. Yes, exactly. Thank you. Yes?
Just a quick one. So moving on from streams, if you're, say, writing a normal controller, when you're working with mutable objects like datetime, for example, if you're not using the immutable version, you'd clone it to protect yourself against any changes. Are there any cases when you would recommend doing that with a controller using the stream to protect against that mutability of the stream?
So the question is, can you clone the stream?
Or you can, or presumably you can, because it's just a normal stream.
Right.
Would you, if you had standard, say, Laravel application or a Symfony application, and you were reading and writing values, and you had a stream, you didn't want any middlewares to affect the stream, so you wanted to protect against that, would it be wise to clone the stream kind of as part of a middleware or as part of your controller?
To be honest, I don't know enough about how the streams work. I mean, like PHP streams, period. I don't know enough about how they work to know whether or not that would be possible. You could probably copy a stream. I know that you can copy a stream to another stream. That would be an option. I think there was one of the subheadings on here. I know that the official recommendation, where was it? Sorry. The official recommendation is to use read-only streams if you're doing a server-side request, because then there's less chance that you can write over those or do something dangerous. You can always reset the stream if you need to go back to the beginning. I think we've run into that a few times where you have to reset it. If someone reads it, you can reset it, but not all of them can be reset, I think is one of the problems. You can't, some of the streams can't. Possibly. I mean, if a middleware is going to do something with the stream, that middleware should be very careful about what it does, and it might make sense at that point to copy the stream or do some other guards. So yes, if you're going to do something with the stream in a middleware, then you should definitely try to do what you can to protect the users either upstream or downstream from you.
All right. That's for many questions. So we can continue on the lunch hour. Thank you very much, Beau, for this. And thank everyone. Please don't forget to give feedback on Joined In. And if you have the app, you can give feedback on the app. And that goes immediately on Joined In. If you don't have the app, check it out. We have the SymfonyLive app going on. Thank you.
Thank you.